Hi guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep, and I, Rakesh Sir, once again welcome you to this concept classes for latches and flip-flop. Yes, as I've been telling you, as we have been discussing that, the concepts of sequential circuit is one of the most important for digital electronics, and to be very comfortable in sequential circuits, you should be comfortable in the latches and the flip-flops, of course. Yes, so in this session, let's get started with the latches. Already we have started with the latches and flip-flops, and we started with unclocked latch, a type of asynchronous circuit. Then we went on towards clocking. First we started with level triggered devices. Once we started the clock, it was level triggered clock. Okay, then we completed all types of clocked latches. Then we understood the problem, something like a race around condition. We identified what is the problem with level triggered devices, and then we eventually moved towards edge triggered devices, that is the flip-flops. We also learned the master slave flip-flop, what is a master, what is a flip, and how the cascade combination of a master and a slave latch becomes a edge triggered device known as the flip-flop, right? And then today we are here to discuss the flip-flop conversions, how to convert from one flip-flop into the another, how to convert from the one flip-flop into the another. So let's get started. And before we start off, come on everybody, do not forget to update your friends about the session. Share the session to everybody, your friends, juniors, whoever might be interested for the GATE 2023 preparation. Just a second guys. Yes, okay. Hi, good evening all, good evening. Keep joining, keep learning. Chalo, so let's get started. In case somebody new to my session, this is a brief intro about me. This is your mentor and educator Rakesh, and I have secured all India rank 9th in the GATE examination, completed my masters from the Indian Institute of Science, Bangalore, and yes, I've trained more than 50,000 students in my 11 plus years of teaching experience in this field. I commonly deal with control system, digital electronics, signal and system, and electromagnetic theory. Yeah, these are the 4 subjects that I commonly deal with in technical domain, and in the general area I deal with the engineering, maths, and general aptitude. Hi guys, good evening. Good evening Navneet, Ruby, AB de Villiers, Prachi, Bhupati. Very good evening. Okay, yes, this is the Hall of Fame. As you know, GATE 22 results were declared, in the month of March, and many of the BYJU'S Exam Prep students have outshined in the examination, having secured all India rank 1, 2, 3. There are multiple ranks under 50, and there are many students who secured AIR under 100. I just hope and pray that, you guys definitely strike similarly in the GATE 2023 exam and the results. Yes guys, and if you want the dedicated GATE preparation courses by the BYJU'S Exam Prep, right, by the expert faculties, and if you want the financial assistance to enroll into those courses, the BYJU'S Exam Prep brings you a scholarship. Yes, get up to 90% scholarship on the courses. You can just appear on the scholarship, prove yourself on this coming Sunday, that is 1st of May at 11 a.m. You can attend this and get scholarships worth up to 90%. Yes guys, another update I've been telling you earlier classes also. Yes, in this current digital age, and yes, everybody is mostly following now online classes, digital classes, not only for classes, not only for GATE preparation, many of the times for university preparation and university exams, GATE preparation, test series is also online. GATE actually is going to be conducted online. Okay, so you practice also, multiple times online mode, you study in the online mode. So it's a complete digital world, you can say, right? We're very habitual of the electronics gadgets now, be it laptops or iPads or mobile phones or anything, even, YouTube and all those things. So at the same time, we also have to, pay attention to our health. So other than the technical classes, other than, just what we teach regularly in our classes, I thought let's have a general problem that students or anybody in this digital world might be facing is all about the stress. How to deal with this stress and anxiety. Our preparation should be best and our health should also not be compromised. So what are some words of advice from my side? We are going to have a small discussion on this coming Saturday at 10 p.m. Saturday at 10 p.m. right? Okay, that is just tomorrow. So tomorrow at 10 p.m. on the same channel. So in case you haven't subscribed to our channel, do not forget to subscribe this channel to get more such sessions and do not miss these sessions. Okay, now let's get started with the content, guys, quickly. Okay, and yeah, one more quick update. A quick update, this everybody knows this is what is the series we are running. So just to give you once again a quick review, this is the sequence. Flip-flop conversion is today. Okay, tomorrow we are going to have state transition diagrams. So state diagrams of all flip-flop, and not only state diagram of flip-flop, we will also take up some good questions based on the state diagram that is discussed in the GATE examination, and the waveform based questions regarding to the flip-flop, waveform and timing analysis based question, right? All this is in the next 2 classes. Now flip-flop conversion. Now I will tell you the techniques and tricks also, but first of all, what is the procedure? First, let's start with the conventional method. Okay, I'm first of all writing down the steps for conventional method, and then we will talk about some simplified tricks. In some of the cases you can apply the tricks also, you can apply the quick results also. Okay, but first let us go through the actual steps. Now, number 1, identify the available and required flip-flop. That will be given in the question, that will be given in the problem statement. What is the available flip-flop and what is the required flip-flop, which flip-flop to which flip-flop conversion is required. Okay, now make the characteristic table for the required flip-flop. Now everybody knows characteristic tables of all the different types of flip-flops. So you just have to write down the characteristic table for the required flip-flop. Okay. Make the excitation table for available flip-flop. Now sir, what is the excitation table? I will explain you that. Okay, I have explained you the characteristic table. So today's class I will also explain you what is the meaning of excitation table and how do you write down the excitation table for any flip-flop, right? Next, write down the Boolean expression for the available flip-flop, right? And once you get the Boolean expression, just simply draw the circuit. So mainly 2 things: characteristic table for the required flip-flop, whatever flip-flop you require, and excitation table of the available flip-flop. Let's have a look into this. A simple problem statement: how to convert a JK flip-flop to T flip-flop. Now guys, in the yesterday's class itself, when we were discussing master JK latch, the master JK flip-flop, there itself I have shown you how a JK latch was behaving as D latch. But that was the reverse analysis. The circuit was given and I shown you yes, this JK latch is working as D latch. Suppose I am blank, right? I am given a JK flip-flop. How can I make it function as a D flip-flop? How can I make it available as the D flip-flop? So now JK flip-flop to D flip-flop means JK flip-flop is given to you. This is known as my available flip-flop. You have to convert this to the D flip-flop. Okay, so that is your requirement. So D flip-flop is the required flip-flop, everybody. D flip-flop here is the required flip-flop, right? D flip-flop here is the required flip-flop. Acha ji. Okay, what I told you, for the required flip-flop, make the characteristic table. Okay sir, I will make the characteristic table here. Make the characteristic table of the required flip-flop. Now D flip-flop is the required flip-flop. So what is the characteristic table? Characteristic table, also known as what? Next state table, transition table, which will give you what is the next state of the device based on the current state and the applied D input, right? There are 2 inputs, the current state and the external D input, and that will have the 4 possibilities. 0, 0, 0, 1, 1, 0 and 1, 1. Now we know that for the D flip-flop, what is the characteristic equation? For the D flip-flop, the characteristic equation is Q plus equal to D, right? So whatever is this is very simple characteristic table in case of D. Whatever is the D value, just copy to the Q plus. So 0, 1, 0, 1. So my characteristic table is complete. Now what to do, sir? After this, take the excitation table of the available flip-flop. So now I will explain you what is the excitation table also. What is the excitation table of this available flip-flop? Now try to understand very clearly what is the excitation table. Excitation table means, okay, when you know what is the current state and what is the next state you want, Okay, you are given the current state and the next state that you want. To achieve that next state, what inputs should be applied? How to excite the flip-flop? What inputs to be applied to the flip-flop to obtain that next state? Good evening, Chandrasekhar. Usually, you are given the input. Based on the input and current state, you decide the next state. But suppose I tell you, this is the current state and this is the next state I want. So, to produce this next state, what should be the value of the input applied? Right. Yes, correct, ABD. What input we have to apply to the system to obtain the given next state? Right. That is what I should write down here. So, a current state and a next state should be mentioned. What is the current state of the latch? What is the next state of that flip-flop? And then to generate that next state, what should be the D input? Now, it is simple for D flip-flop. But yeah, we'll have to see for other flip-flops also, right? Now, here there are two variables, so write down all four combination of two variables, 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0, 0, 1, 1, 0 and 1, 1. Write down the values, all possible values here, okay? Write down the all possible values here. Now, what should be the value of D? Now, to obtain the Q plus, what should be the value of D? Now, once again we know that the Q plus is directly equal to the D. Right. So if you want the Q plus equal to 0, the D should also be 0. If you want the Q plus equal to 1, the D should be 1. 0 to 0, 1 to 1. Okay. Now we have to convert both. What was the last step? Excitation of JK flip-flop. That will also come. Don't worry. For D flip-flop, I know it is very simple. The good thing is, can you make excitation table of JK flip-flop? That also as an activity. Within one problem, we will take that also, ABD. Don't worry. Right, in the entire class we'll cover entire thing, don't worry. Now I told you, write down the Boolean expression. Kya karna hai? Now write down the Boolean expression for available flip-flop. What is the available flip-flop here? The available flip-flop is the D flip-flop. Sorry, the available flip-flop is the JK flip-flop. Oh, sorry guys. We have to make the excitation table of the available flip-flop. That is the JK. Yeah, I'm sorry for a moment. Yeah, we'll reconvert it. We have to make the excitation table of the JK. Okay, so for a moment I forgot that the available flip-flop is JK. But now we can write down again. Now everybody come. Yes, ABD. Bilkul sahi. JK hoga. Right. So what was that? Write down the excitation table of the JK flip-flop. So just discard the previous table and now let us focus here. Now, try to understand the excitation of table of JK flip-flop. Q and Q plus. Q is 0, Q plus should be 0. The current state is 0, next state should also be 0. There are two cases. Either the device, you can understand that either the device remains in the same state. 0 to 0, device is in the same state. And now think reverse. When is the device in the same state? When JK is 0, 0. So this is JK 0, 0. Or there is one more way of thinking. What is that one more way of thinking? Q is 0, Q plus is 0. Maybe somebody has intentionally reset. The device. And how do you reset the device? What is the JK input to reset the device? Which input will reset the device? K input. So it should be J0 or K1. It should be J0, K1. So one thing is fixed. J should be 0. One thing is fixed, guys. Ki J should be 0. But K can be either 0 or 1. I can write like this. K can be either 0 or 1, but J should be 0. Looking into both the possibility. And because K can be either 0 or 1, right? So that means K is in the don't care state. Because there is no other possibility other than 0 or 1 in binary. So it may be 0, it may be 1. Right? If the J is 0, this state transition is guaranteed. K goes into don't care. Whether it is 0, whether that is 1, no problem. Does not matter. Is it okay? Okay, so 0 and X. Here we go, 0 and X. Now, next 0 to 1. Current state 0, next state 1. What can you think now? Current state is the 0, next state is the 1. Maybe you are toggling the device. What is the correct input to toggle the device? 1, 1. What is the correct JK input to toggle? 1, 1. Right? Or maybe you can think like current state is 0, next state is 1. Means next state is set. So maybe somebody is trying to set the device. Maybe somebody is trying to set the device. What is the correct combination to set a JK flip-flop? J equal to 1, K equal to 0. J equal to 1 will set the device, or it may be 1 0 possibility, J1 K0. So what is common in both? J should be 1, K can be either 1 or 0, right? What is common in both? J should be 1, K can be either 1 or 0. Once again, because K can be in either 1 or 0 state, matlab K is don't care. K can be anything. Either 1 or 0 does not matter. But if J is 1, this transition is guaranteed. This transition is what is guaranteed, right? So ye raha yahan pe X. Don't care ke liye I put down the X. Now everybody quickly. 1 0. Current state 1, next state 0. Again a possibility of toggle. Again a possibility of toggle, and toggle occurs at 1 1. Next, current state 0, next current state 1, next state 0. Next state 0 means think about reset. Next state 0 means you can try to reset the device, and reset occurs for J0 K1. J0 K is anyways 1. So what is the guarantee here? J can be either 1 0, matlab J can be anything, but K has to be 1. K has to be 1. So let me write down this result here. J can be anything, K has to be 1. Now guys, last case, 1 1. Q and Q plus 1 1. Q and Q plus 1 1 means the current state is 1, next state is also 1. One direct possibility is no change of state. Same state. Same state is guaranteed for 0 0 input. The same state is guaranteed for the 0 0 input. Number one possibility. The same state is guaranteed for the 0 0 input. Acha, what should be the next? What should be the next? 1 to 1. So current state 1, next state 1. Next state 1 means the device is set. You can think like that also. Device is set if J is 1, K is 0. So what is common? K has to be anyway 0. J can be either 0 or 1. J can be either 0 or 1. So J can be in the X state. So this is known as the X0. This is known as what? This is known as the X0. This is the final thing. This is the final thing, right? So this is the excitation table. Okay. Now write down the Boolean expression for the available flip-flop. What is the available flip-flop? JK flip-flop. So now we have to actually mix both, right? We have to actually mix both. See, I have Q, D, Q plus, that is known as the characteristic table of the D flip-flop. That is known as the characteristic table of the D flip-flop, and based on the Q plus transition, I have to write down the excitation table for the JK flip-flop, right? I have to write down the excitation table for the JK flip-flop. Okay, just keep on looking into this quickly, right? QD 0 0 0 1 1 0 1 1. Now what is Q plus? What is Q plus? Q plus equal to D. This is the characteristic equation part. This is the characteristic table part, and this is the excitation table part, right? Q plus equal to D. So 0 1 0 1 is copied. Now based on the Q plus transition, I have to write down the excitation table, right? And that is already done. Let us not repeat that. 0x 1x. Let us write down this value. 0x 1x x1 x0 x1 x0 x1 and x0. Now based on this table, you have to decide what is J. Now J, right, and K as a function of Q and D, as a function of current state and the input D. So two variable K map will come here. Very simple. Two variable K map will come up here. Don't care is also involved. So what is the two variable K map for J? Now here I write Q, here I write D. Now the truth table of J is 0 1 x x. What is the truth table for K? Let me first make the K map, feed the truth table into the K map. This QD, and K is x x 1 0 x x 1 and 0, right? Now okay, here this 1 can be paired with this x, this one is paired with x. We all know that it is not necessary to use all the don't cares. Use them only if they help you in pairing. So this 1 and 1 can be paired. This is Q, so this is 0 1, D ka 0 1 combination. So here it is very simple that J directly lies in the column where D is high, right? J is equal to the D. J is equal to the D. What about the K? K lies, this is the column where D is high, so K lies outside that, so K should be equal to D bar, right? So to complete this design, J should be equal to the D, K should be equal to the D bar, J should be equal to the D, K should be equal to the D bar, J should be equal to the D, K should be equal to D bar. This is the final circuit diagram. This is how a JK flip-flop is converted to D flip-flop, right? Internally it is a JK flip-flop, right? But you apply D to J and D bar to K, the final functionality will be a D flip-flop. And we have learned that yesterday also. Yesterday we did the reverse analysis. Given this diagram, we understood that it is behaving as D. I made it understand through equation also. Okay? I made it understand through equation also. This is the answer. That's it. This is the final answer, you can say. Right? This is the final answer that you can say. Acha, can you solve it by logic? Can we try to solve it by logic, by intuition? Okay, rather than solving these many tables, can we solve it by logic? Dekho. What is available? Available is the JK flip-flop. So what is the next state equation for JK flip-flop? JQ bar plus K bar Q. What is the required flip-flop? What is the required flip-flop? D. So what is the next state equation of the D flip-flop? Q plus equal to the D. Now understand, see, this is tricks. Here you have to apply your own brain. There is no specific method. Here we have to apply our logic and brain. Try to understand how can I do it. Now I want Q plus equal to the D. Okay, D is the external input, but in the D flip-flop equation, there is no Q. There is no Q. Q plus depends only on D, but it doesn't depend on the current state. It does not depend on the current state. There is no Q, right? So it is very much clear, okay, that there is no Q. Now because there is no Q, have a look into this. Have a look into this. Q plus equal to JQ bar plus K bar Q. My logic says that Q plus Q bar is 1. Everybody knows that, na? Everybody knows that. देखो यहाँ पे मैं लिख देता हूँ. This is independent of Q. This is independent of Q. And how can you eliminate Q? Q plus Q bar will be equal to the 1. Q plus Q bar equal to 1. That is the logic coming into my mind. So Q plus Q bar can only be added if J and K bar are common. Like Q plus Q bar plus Q can only be added if J and K bar are equal, so that you can take common. So let J equal to K bar equal to some name D. I keep on telling you from the first class, name can be anything. We have set specific name like D, SR, JK due to some logic, due to some understanding of the circuit that I have explained you earlier. Let J equal to K bar equal to D. So जैसे ही मैंने किया, so what happens? Q plus is equal to D Q bar plus, now what is K bar? K bar is also equal to D, right? So that I can take the D common. Q plus Q bar is 1, so I get D into 1. Final answer is D, and hence by this logic I am simply able to say that you can convert a JK latch into D latch by putting J equal to D. Right, this gives you two conclusions. Put down J equal to D and K bar equal to D. So what should be K? If K bar is D, K should be equal to the D bar. Logic, simple, intuition. In few seconds you can solve the problem. So that is what we have actually derived. J should be equal to D, K should be equal to D bar. K should be equal to D bar. That is what we have derived by the table also. J equal to D, K equal to D bar. That is the intuition method. So we know both the methods. We know the proper procedure. We know the intuitions. Right? Chalo, let us take one or two more. And finally, as a result, I will give you all conversions. Finally, as a result, we'll give you all conversion. Right, let us come here. Okay, so this is done, JK to D. Now let us start step by step. Now guys, how to convert SR into other? I am not taking, you can try the whole procedure, you can try as a homework, but I am not trying for SR to D, SR to JK. Why? Because if you follow the first two classes very clearly, if you follow the first two classes explanation, Very clearly, first I explained you about the SR design, and based on the SR design only I converted to D, I converted to JK, I converted to the T, right? So if you followed the first two classes, then no need for this understanding, because whenever we were discussing about D flip-flop, I told connect D to S and D bar to R. It becomes a D flip-flop. You can just go through the first two classes. Here I am just giving you as an answer so that it is available in our notes, so that it is available in the PDF. Okay. So just because I told you about PDF, so let me just put a reminder that both the PDFs, yesterday and today. Yesterday password already given, you can see in the yesterday's class only. Yesterday was about the flip-flops, race around condition and master slave flip-flop. Today we are talking about flip-flop conversion, and just a reminder that PDF will be there in the Telegram group, and the PDF will be password protected, and the PDF today's password will be FFCONV, F flip-flop conversion. Randomly I framed FFCONV. Okay, so if you want to download the PDF from the Telegram, use this particular password, FFCONV, right? So SR to D, SR to JK, when we were designing SR to JK, we took one more level of feedback. Okay, and then when you make J and K both common, that becomes a T flip-flop. That becomes a T flip-flop. So I'm not explaining this part because this is what I think we have already covered in the first two classes. Let's go to the next. D flip-flop to JK flip-flop. D flip-flop to JK flip-flop. How can we do that? Converting a D flip-flop to the JK flip-flop. Can we do that? Converting a D flip-flop to the JK flip-flop. How can we do a conversion from D flip-flop to the JK flip-flop? Everybody. This is very simple. Why this is very simple? If we go not by the proper derivation, I don't want the derivation. Okay, I just want a very simple logic. Very simple logic, right? JK flip-flop. Q plus is JQ bar plus K bar Q. For D flip-flop, Q plus is equal to D. Right? Q plus equal to D. Right? So what you have to do, simply let D is equal to JQ bar plus K bar Q. Right? So what is the answer? Try to see. What is the flip-flop available? D flip-flop is available. So this is D. These are the two outputs, Q and Q bar, and this is the clock. Right? This is the clock. Now I want to convert D to JK. I want the D to JK. So for that, what you only have to do, D equal to JQ bar plus K bar Q. JQ bar plus K bar Q. JQ bar. Yeah, ठीक है. As a regular notation, इसको ऊपर ले लेते हैं, no problem. JQ bar and K bar Q will come. This has to be ANDed with what? ANDed with a variable known as J plus K bar into Q. Now these have to be added. To add them, let's use a logical OR gate. Right? This becomes the D. And this is what? By the intuition. I'm not deriving by the complete truth table method. We can do that, but many things we can try to solve directly. Many things we can try to solve directly if we know the equations. So we want, this is what we want. I want JK flip-flop which implements JQ bar plus K bar Q. I have a D flip-flop which implements Q plus equal to D. Right? So why not only design D by a Boolean logic? If I make D equal to JQ bar plus K bar Q, so Q plus will be equal to D. That will be further equal to JQ bar plus K bar Q, and ultimately we get our required characteristic equation. We get the required flip-flop. This is the answer. This is the answer, everybody. Have a look into this. Have a look into this little bit more neat and clean systematic diagram, but the same thing I have drawn here. Right? So I have converted a D flip-flop to the JK flip-flop. Right? Similarly, we can, convert a D flip-flop to the SR flip-flop, because what we have, Q plus equal to D, and for SR flip-flop, what is the Q plus? S plus R bar Q. So make the D equal to S plus R bar Q. So this is R bar. This is the Q variable. They are ANDed. This is R bar Q. This is S. So this is simply S plus R bar Q. Problem solved, na? By simple logic, in few seconds, you should be able to convert D flip-flop to the T flip-flop, D flip-flop to the T flip-flop. So D flip-flop is Q plus equal to D, and T flip-flop is Q XOR with T. What is the T flip-flop equation? That also we learned in the previous classes. Now that is T XOR with Q. So nothing you have to do. Let the D equal to Q XOR with T. Okay, I have the D flip-flop available. Right, this is Q and Q bar. This is my regular clock variable. Now I have to take Q, use a external OR gate, and XOR the Q with the variable T. Done. This is what is Q XORed with T. Q XORed with T. That's it. Done. Yeah, these are very, very helpful tricks, and you can expect the questions on this in the competitive exams, right? Logic, play with it, digital logic. So we have to play with logic. We cannot be conventional in each and every type of question, especially for the competitive exams. Right, chalo, this is done. Now that is the answer of this. We have drawn already. That is the already answer. JK flip-flop to D flip-flop already discussed. Now this was the first problem, so it's a copy. So I'm taking flip-flop to flip-flop. Now JK flip-flop to D flip-flop covered. JK flip-flop to T flip-flop. Remember the first two classes only. How do you convert the JK to T? Just commonly tie J and K. Just commonly tie J and K and name it as T. It is automatically a T flip-flop. So that is a fundamental. Here you don't have to apply any method, any trick. That is fundamentals. If you have gone through the basics, that is why we study each and every type of device first with the basics, right? So this is done JK. Acha, I am not taking JK to SR. I am not taking JK to SR because it is meaningless. Why it is meaningless? I am not taking JK to SR because it is little meaningless. Actually, SR should be converted to JK. SR has a problem. SR has a problem of invalid state. SR has a problem of the invalid state. SR has the problem of, so just a second, let me mention here, JK to SR, I am not doing, right? This is not practically useful. Why? Why? Because SR has invalid state problem. Invalid state problem, which is overcome by JK, right? So JK overcomes SR. So why to go reverse, right? Okay, so why to design reverse? There is no point, na? Why to go into problematic state when you already have a JK flip-flop which eliminated the problem of invalid state? So that is why I'm not preferring it. Going to the T to JK. Now JK to T is very simple. JK to T is very simple. Commonly tie both. What about the T flip-flop? Given the T flip-flop, getting to JK flip-flop. Given the T flip-flop, getting it to the JK flip-flop. Now let us try to understand this. Right? So guys, let's try to complete this problem again. So one more problem let us take by conventional method, so that we have developed the tricks also, right? And so that one more conventional practice you should have, because only one conventional practice we had, one more conventional practice we'll have. So T flip-flop is known as the available flip-flop. JK flip-flop is known as the required flip-flop. This is the available flip-flop. What do you do for required flip-flop? Guys, steps. For the required flip-flop, you should make the characteristic table. For the available flip-flop, you should make the excitation table, right? For the required flip-flop, characteristic table. What is the required flip-flop? JK flip-flop, right? So Q, J, K and Q plus. Excitation table for T flip-flop. Q and Q plus. Based on that, what is the value of T? So guys, this we anyways knows, this we can fill it up. Isko baad mein fill kar lenge, no problem. But let us fill the excitation table. So with this problem, we will also cover excitation table of the T flip-flop, right? So now, first of all, current state and next state, there are two variables, so four possibilities: 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0, 0, 1, 1, 0 and 1, 1. Okay? Then there is a T input. As I explained you about excitation table, based on the state change, based on the given current state and next state, what should be the input? What is the input that you should apply? How you should excite the flip-flop to obtain the next state Q plus, right? So 0 to 0 means same. Yeah, ABD, I explained you in the previous classes. T means toggle. T is for toggle only, right? 0 to 0 means same state, and to maintain the same state, T should be 0. 0 to 1 is toggle, complement, and to complement the flip-flop, you should have T1. 1 to 0 is again toggle, so T should be 1. 1 to 1 is same, and for same state, T should be 0. For the same state, T should be the 0, right? For the same state, T should be 0. Okay? No, 1 does not mean toggle. T means toggle, Navneet. Like 0 to 1 is toggle, 1 to 0 is also toggle, right? 1 to 1 does not mean toggle, 1 to 1 means same. Okay, so this is what. Now let us not fill it here. We'll fill it directly here, because ultimately I told you, ultimately we have to merge both. So Q, J, K, then we have Q plus, and then we have T. And then we have T, right? Make the Boolean expression for the available. That's what I told you. Q, J, K, Q plus and T, right? This is what is the characteristic table part. This is what is the excitation table part, and you need to look into a transition from Q to Q plus to design the excitation part, right? Now, Q, J, K will have three possibilities: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, right? Yeah, reverse you are telling, Navneet, correct. Whenever T is 1, then toggle. Okay, that is correct, Navneet. Okay, now look at the Q plus. So JK 0, 0, same state, 0 ka 0. JK 0, 1, reset. JK 1, 0, set. JK 1, 1, toggle, to 0 ka toggle, 1. JK 0, 0, same state, to 1 to 1. JK 0, 1, reset. JK 1, 0, set. JK 1, 1, toggle of current. 1 ka toggle, 0. Now you only need to see Q plus to design the value of T. Everybody carefully. 0 to 0, same matlab T 0. 0 to 0, same. 0 to 1, toggle. Whenever I say toggle, just keep writing 1. 0 to 1, toggle. 1 to 1, same. 1 to 0, toggle. 1 to 1, same. 1 to 0, toggle. That's it. Now write down it's a 3 variable function, T as a function of QJK. So we have to now make a 3 variable flip-flop, or 3 variable K map. We have to now design a 3 variable K map. This is Q, this is known as the JK. This is the Q and that is known as the JK, everybody. Right? Q and JK. Chalo. Now let us come and fill. So Q 0 1, JK 0 0 0 1 1 1 1 0. Right, and then this is the Q high, this is J high, 0 1 1 1, that is the K high. Now let us fill. So when I fill 0 0 1 1, then I have 0 1 0 1. This is the filling, and now we just need to pair it up. This is a clear pair of 2. This is again a clear pair of 2. This is J and outside Q, J Q bar, and this one lies where? This one lies where? This is the table that you have to copy, hai na? 0 0 1 1 0 1 0 1, correct. And this is what? This is K into Q. This is K and Q. Right. So what should be the T input? T input is known as JQ bar plus KQ. T input is known as the JQ Q bar plus KQ. So to convert T flip-flop to JK flip-flop, we have to make the T input equal to JQ bar plus KQ. Have a look into this, the direct answer. Right, look into this again. JQ bar plus KQ. JQ bar, this is J and this is Q bar. So this is JQ bar. This is directly K and then ANDed with Q. So this is KQ, and then I add JQ bar plus KQ and feed to the T. Feed to the T input. That's it. T flip-flop to the JK flip-flop is complete. T flip-flop to the JK flip-flop is complete. This is the conventional method. This is the problem which is again solved by the conventional method. Everybody. Right. T flip-flop to SR flip-flop, just we can retry that problem and you can again solve it up by the similar procedure. T flip-flop to D flip-flop. One more case. T flip-flop to D flip-flop. Now, once again, I will solve this problem by the intuition. You want D flip-flop, which is Q plus equal to D. T flip-flop is given to you. T flip-flop is Q XOR T. Q XOR T. Right. So, I again want to eliminate Q. To see what I am going to feed. To eliminate Q, I will use T equal to Q XOR D. Why? Because what is Q XOR Q? Is 0. XOR of same bits will give 0 result. Na? So, this is now 0 XOR D. What is X XOR 0? What is X XOR 0? X. What is D XOR 0? Will be D. So eventually you get Q plus equal to D. So what is the answer? So you just have to let T equal to the Q XOR D. T is equal to Q XOR D. You can once again try with the conventional method. But this is what is the logic method. So there your brain has to work. Quickly, T is equal to Q XOR D. So this is what? Q XORed with D, feed to T. That T flip-flop will behave as a D flip-flop. Simple. Very simple. And now I think by this time all flip-flop conversions completed. We have taken all flip-flop SR, D, JK and T and converted to all other flip-flops. Every case we have seen. So once again a reminder before we call off the class that Saturday at 10 p.m. that is just tomorrow guys, at the same channel 10 p.m. right, we have a session, important session to maintain a very good balance between our preparation, which is mostly through digital technology right now. So we are living in the digital age, and if it is causing some anxiety, stress, okay, let us try to balance our health also. So how to make a correct balance between our health and our primary focus, that is the preparation. Okay, that should maintain. So even if you are in any mode, if you are studying online, in any case, do not forget to join me live. Few suggestions from my side to be discussed in this session. Right, this is the schedule of the current series once again as a reminder. So tomorrow is 30th of April guys, and tomorrotomorrow we are going to talk about the state diagrams. State transition diagrams. That is the next class coming up live tomorrow. Same time for digital, you have to join me live on the same channel, that is at the 8 p.m. Do not forget to subscribe the channel to attend all these sessions, technical sessions. Very soon we'll bring you maths and aptitude sessions also. And other than that, general guidance sessions like, how to deal with the digital stress and all those things we are bringing. So keep subscribed. And if you have learned the tricks and conventional, both the things we have covered in today's class, one is the detailed conventional method, right, perfect for everywhere, and most of the cases we are able to apply our intuition, our logic, the logic of digital logic to solve the problem. If you have got hold of both, if you have enjoyed the session, do not forget to like it up so that we come to know that yes, students are actually enjoying. So put your response. Do not forget to like the session if you have enjoyed, right? So that's it guys. Let's connect tomorrow once again at 8 p.m. That's it from my side, and do keep subscribed to our channel. Okay, bye bye. Thank you. Stay safe and take care of yourself.